Hello everyone, welcome to this video on solutions of homogeneous linear PDE. So in this video we are going to see how to solve homogeneous linear partial differential equations. So first let us see what is a homogeneous linear PDE. So homogeneous linear PDE means it's a linear PDE in which the partial derivatives occurring are all of the same order. So if the partial derivatives occurring in that are all of the same order, then we say that it is homogeneous linear PDE. Why it is linear? If the degree of that equation is 1, then we can say that it is linear. Otherwise, it is called a non-homogeneous linear PDE. So, an equation of the form A naught dou power n z by dou x power n plus A1 dou power n z by dou x power n minus 1 into dou y power 1 plus A2 into dou power n z by dou x power n minus 2 into dou y square plus and so on plus an into dou power n z by dou y power n is equal to f of x comma y is nothing but a homogeneous linear PDE of order n. So here the partial derivatives are all of the same order. So that is why it is called a homogeneous linear PDE of order n. And then here the degree of that derivatives are 1. Okay. So that is the power of that derivatives are 1. So it is linear. That's why it is called linear homogeneous partial differential equation of order n. So we have nth order derivatives. So in all terms we have nth order derivatives. That's why it is called homogeneous partial differential equation of order n. And it is also linear since the power of the derivatives are 1. So here we can take this dou by dou x as capital D and dou by dou y as capital D dash in 1. Then we can rewrite this equation in this form. A naught d power n plus a1 d power n minus 1 into d dash plus a2 d power n minus 2 into d dash square plus and so on plus an d dash power n into z is equal to f of x comma y. Further it can be simplified like this. We can write that is because in the left hand side we have a function of d and d dash. So I can write the left hand side is nothing but a function of d and d dash into z, and the right hand side will be having a function of x and y. So this is what the simplified form of a homogeneous linear PDE of order n. So now in this video we are going to see how to solve a homogeneous linear PDE of order n. So here the general solution of this homogeneous linear PDE will consist of two parts, namely complementary function and particular integral. So here in this PDE, that is we are having our PDE in this form f of t comma d dash into z is equal to f of x comma y. So in this form, by considering the left hand side, we find our complementary function, and by considering our right hand side, we find our particular integral. Suppose if the right hand side is 0, that is if we have our equation in this form f of d comma d dash into z is equal to 0, then complementary function alone gives the general solution. So the general solution z would be CF alone. Otherwise it is CF plus PI here. So now first let us see how to find this complementary function. Okay, for we are going to consider the equation in this form. So if there is no right hand side, so we can find only the complementary function, and complementary function alone gives the general solution z. So here for finding the complementary function in this equation we are going to replace d as m and d dash as 1, and then we write our auxiliary equation as f of m comma 1 is equal to 0. So writing the auxiliary equation f of m comma 1 is equal to 0 and solving the auxiliary equations, you can find out the roots as m1, m2 and so on mn. Say, suppose if all the n roots are distinct, then we write the complementary function as phi 1 of y plus m1x plus phi 2 of y plus m2x plus phi 3 of y plus m3x plus and so on plus phi n of y plus mnx. Suppose if all the n roots are same or repeated. Okay, so the complementary function takes this form, that is z is equal to phi 1 of y plus m1 x plus x into phi 2 of y plus m1 x plus x square into phi 3 of y plus m1 x square into plus and so on plus x power n minus 1 into 5 plus m1 x means what? If all the roots are same that are equal to m1 means what? We don't have distinct roots. We have only one root. So everywhere we are replacing here that m1. Okay, and for the second term we multiply it by x, and for the third term it is x square. Like that we write our general solution. So now let us see some examples in this. So this is our first example. So here first we have to write, actually we have the given equation in this form, f of d comma d dash into z is equal to 0. So first we have to write the auxiliary equation. The auxiliary equation is written in this form, f of m comma 1 is equal to 0. Means what? In the given equation 1, we take d as m and d dash as 1. So in the given equation, if we take d as m, it is m squared minus d as m, here d dash is 1. So it is minus 4m plus d dash is 1. So it is 4 is equal to 0. So solving this, we can find out the roots as, so here the product must be 4 and the sum must be minus 4. So it is minus 2 into minus 2 gives plus 4 and the sum is minus 4. So it is my m minus 2 into m minus 2 is equal to 0. So the roots are m is equal to 2 and 2. So we have got two roots and the two roots are the same. Means we have repeated roots. So how to write the complementary function for this case? The complementary function alone gives the solution z. So which is written as phi 1 of y plus 2x plus x into phi 2 of y plus 2x. That's it. So this is our second example. So here we have to solve d cube minus 6d square d dash plus 12d d dash square minus 8 d dash cube into z is equal to 0. So we have our equation in this form, f of d comma d dash into z is equal to 0. So here first we have to write the auxiliary equation. So the auxiliary equation is written as f of m comma 1 is equal to 0. So here we are replacing d by m and d dash by 1. So we get m cube minus 6m square plus 12m minus 8 is equal to 0. So here we have a cubic equation, and for solving this we can follow the synthetic division. So using synthetic division, writing the coefficients of all the terms. So it is 1 for m cube, the coefficient is 1, for m square it is minus 6, and for m it is 12, and we have to write the constant term at the end. So now I'm going to solve this. Since I'm having an even number, I'm going to check whether 2 satisfies this or not. So here always we have to put 0, then 1 plus 0 gives 1, and here 1 into 2 is equal to 2 here. So here addition, that is minus 4. Here product, so it is minus 8. 2 into minus 4 minus 8. Now addition gives 4, and now product 2 into 4 gives 8. Yes, 2 satisfies this equation because we get the remainder as 0 here. We get the remainder as 0 means what? 2 satisfies this cubic equation, which means 2 is one of the root. So how can I write this? M is equal to 2, and this can be written as a second order equation. Okay, that is what? M square minus 4m plus 4 is equal to 0. Now solving this quadratic equation, we can find the remaining two roots. So which is similar to the previous problem. So here the roots are m minus 2. M minus 2 is equal to 0 implies that we get m is equal to 2 and 2. So already we have got one of the root is 2. So here the roots are, all the roots are the same. The roots are m is equal to 2 comma 2 comma 2. So how can we write our CF? Which is our complete solution, that is CF is equal to phi 1 of y plus 2x plus x into phi 2 of y plus 2x plus x square into phi 3 of y plus 2x. So this is our third example. So here first we have to rewrite the given equation. Okay. So how to rewrite the equation? Dou square z by dou x square. We know that we use capital D for dou z by dou x and d dash for dou z by dou y. Okay, so using this I'm going to write the given equation first in this form f of d comma d dash into z is equal to 0 form. So how can I rewrite the given equation? That is nothing but it is d square plus 4 into we have dou z by dou x and dou z by dou y, the middle term. So it is 4d into d dash, and in the last term it is only dou square z by dou y square, means 5 into d dash square into z is equal to 0. So this is what our given equation. I have written the given equation in this form. So next I have to write the auxiliary function or auxiliary equation, auxiliary equation of the given. So the auxiliary equation is replacing d by m and what? D dash by 1 we get. So this is how we are writing the auxiliary equation. So here the auxiliary equation is m square plus 4m minus 5 is equal to 0. And for solving this, the product must be minus 5 and the sum must be 4. So it is minus 1 plus 5. So the roots are m minus 1 into m plus 5 is equal to 0. Implies gives that m is equal to 1 and m is equal to minus 5. So now we can write the complete solution. That is phi 1 of y minus phi x plus, since the roots are distinct, it is phi 1 of y minus phi x plus phi 2 of y plus x. Okay. So I've taken the negative root first and then the positive root as the second one. So next, this is our next problem. So here first again like the previous one, I'm going to write this is in the form of f of d comma d dash into z is equal to 0. So it is d cube minus 7 into here d dou cube z by dou y square and dou z by dou x. So dou z by dou x is d and dou square z by dou y square is d dash square. So it is 7d d dash square plus 6d dash cube into z is equal to 0. Means from this how can we write the auxiliary equation? Replacing d by m and d dash by 1, it is m cube minus 7m plus 6 is equal to 0. There is no m square term, but it is a cubic equation. So I'm going to find out the roots using synthetic division. So writing the coefficients of m, so it is 1 and the middle here m square term is missing, means the coefficient is 0 and the coefficient of m is minus 7 and next we write the constant term, it is 6. So again here I'm having an even number at the end, so I'm going to check whether 2 satisfies this equation. So now we have to put always 0 here. So 1 plus 0 is 1. So 2 into 1 it is 2 and 0 plus 2 it is 2 and 2 into 2 it is 4. So it is minus 7 plus 4 is minus 3 and 2 into minus 3 is minus 6. Yes, 2 satisfies this equation. So one of the root is m is equal to 2 and writing this as a quadratic equation we get m square plus 2m minus 3 is equal to 0 and solving this the product must be minus 3 and the sum must be 2. So it is minus 1 plus 3. Minus 1 into 3 gives minus 3 and the sum gives 2. So it is m minus 1 into m plus 3 is equal to 0. So from this we get m is equal to, from this we get m is equal to 1, from this we get m is equal to minus 3 and already we have got m is equal to 2. So these are the three roots we get from the given equation and all the three roots are distinct here. So how to write our complete solution z here? Phi 1 of y minus 3x, first I have taken the negative root plus phi 2 of y plus 1x plus phi 3 into y plus 2x. Similarly, you try this problem and tell me the answer. Okay. So I hope you understand this. So we'll meet in the next video. Thank you.